Refrigerant 134A enters a compressor at 160 kilopascals as a saturated vapor with a flow rate of 0.35 cubic meters per minute and leaves at 500 kilopascals. The power supplied during the compression is 1.42 kilowatts. What is the temperature of the refrigerant at the exit of the compressor? As usual, pause here and try solving this yourself before watching the solution. This is the first example for the Turbines, Compressors, and Pumps main lecture. The link to that 9-minute lecture and all the other lectures of the thermo course are found in the description below. Since the equation we obtained from the main lecture video for compressors simplifies to the power being the mass flow rate times the change in enthalpy, in minus out, we see that to find the temperature at 2, we first need to find the specific enthalpy at 2. Solving for the specific enthalpy at 2, we see that we need the mass flow rate and the specific enthalpy at 1. To calculate the mass flow rate, we need the volumetric flow rate, which we have, and we need to find the specific volume. At the inlet of the compressor, we're told we have saturated vapor. Therefore, we go to saturated mixture tables, for pressure in this case, and write down the specific volume Vg at 160 kilopascals. And since we're here, write down the second value we need, which is the specific enthalpy Hg for our enthalpy value at state 1. With this Vg value and doing a simple unit conversion, we find the mass flow rate. We substitute the mass flow rate, the specific enthalpy at 1 that we just wrote down, and the power to calculate the specific enthalpy at state 2. Now that we have the specific enthalpy, and since we're given the pressure for state 2, we look up superheated tables for R134A, specifically for that pressure, and find the temperature that corresponds to that specific enthalpy value. To do this, we need to interpolate. We see that 271 is between 267.73 and 276.27, which correspond to 50 and 60 degrees Celsius. We do a simple interpolation and check the interpolation examples linked below if you forgot how to do this, and find that the temperature is 54 degrees Celsius. If you want to check out other examples in the turbines, compressors, and pumps topic, make sure to check out the links I left down in the description below. You'll find the links to the other lectures of the thermal course as well as other engineering courses. Thanks for watching.